In today's lesson, we'll be learning about common factors. More specifically, we'll be learning about monomial common factors. Just to refresh your memory, a monomial is a single term. It can be a number, it can be a variable, or it can be a combination of the two, such as 7x. Here are the key concepts for today's lesson. You should go over these on your own, but the main point here is factoring and expanding are opposites. Therefore, once you factor an expression, you can always double check to see if you're correct by expanding. In our first example, we want to factor the expression 6x plus 3. Let's first rewrite this question. 6x plus 3. The first step in factoring is to look at all of the numbers which are present. They may be coefficients, they may be constants. Here we have a coefficient of 6, and here we have a constant of 3. We are going to ask ourselves, what is the greatest common factor of 6 and 3? So let me write that on the side. Greatest common factor of 6 and 3. You can probably figure this out in your head, or you can use prime factorization. The greatest common factor of 6 and 3 happens to be 3. The next thing you want to take a look at are the variables. We have two terms here. One of the terms contains an x. The other term does not contain any variable. Therefore, there are no variables which are common between these two terms. I'm going to write that on the side. I'm just going to write NA. At this point, I'm going to factor out my 3. When you factor out your 3, you want to put your original expression in brackets. When you're factoring out something, you're really just dividing out a number, a variable, or a combination of the two. So in a sense, we are dividing both these terms by 3. At this point, we just need to simplify some of these numbers. The 3 remains the same. 6 divided by 3 is 2. The x remains the same. 3 divided by 3 is 1. Therefore, we've just factored our expression of 6x plus 3. When factored, it becomes 3 bracket 2x plus 1 bracket. If you wanted to check your work, you could apply the distributive property and you would get the question. And if you get the question, then you've found the correct answer. I'll show you what I mean by doing that down below. If you wanted to check your work, let's just rewrite our answer. And like I was saying, if your expression, once you've applied the distributive property, looks like your question, then you've done it correctly. So 3 times 2 is 6. The x stays the same. 3 times 1 is 3. And as you can see, you get your question again, which means we've done our work correctly. And I'm just going to make a little note here that we've just checked our answer. In our second example, we want to factor the expression 8x squared minus 7x. I'm going to rewrite the question. 8x squared minus 7x. First thing I want to do is look at the numbers in this expression. I have a coefficient of 8 here, and I have a coefficient of 7. On the side, I'm going to write, what is the greatest common factor of 8 and 7? You can use prime factorization, or if you're good at your times tables, you should figure out that the greatest common factor of 8 and 7 is 1, because 7 is a prime number. The next thing we want to look at are the variables within these two terms. These two terms have a variable in common. That variable happens to be x. Now, one of them is to the power of 2, and the other one is to the power of 1, but the 1 is not written in since it's considered redundant. We want to use the lowest power. So x to the power of 1 is a common variable within these two terms. Just like in the previous example, we want to factor out the greatest common factor as well as the common variable. Now, since the greatest common factor is 1, it becomes a little bit redundant to factor out a 1, but I'm going to do that anyways just to show you it doesn't really have an effect. So I'm going to write 1x to the power of 1. I'm going to rewrite 8x to the power of 2 minus 7x. And I'm going to divide both of these terms by 1x to the power of 1. Again, a lot of the work that I'm doing is redundant. So 1x to the power of 1 stays the same. 8 divided by 1 is just 8. And x squared divided by x to the power of 1. Remember, when you're dividing powers with the same base, you just subtract the exponents. So 2 subtract 1 is just 1. Now, 7 divided by 1, pretty simple, that's 7. And again, x divided by x, that is x0, or just 1, because anything divided by itself is equal to 1. However, I'm just going to be consistent with applying the power rules. And again, a lot of the things I'm doing here are redundant. So let's simplify this. Both of these ones should not be written in. So I'm just going to leave it as x. This one really shouldn't be written in, so I'm going to leave that as 8x. X to the power of 0 is equal to 1, because anything to the power of 0 is 1. So 7 times 1 is just 7. Therefore, when factored fully, our expression 8x squared minus 7x actually becomes x bracket 8x minus 7. And of course, you can always check your work by using the distributive property. In our third example, we want to factor the expression 25k to the power of 6 plus 15k to the power of 4. The first thing I want to do is rewrite my question. 25k to the power of 6 plus 15k to the power of 4. Let's take a look at the numbers that are in these two terms. I have a coefficient of 25 here, and I have a coefficient of 15. Let's find the greatest common factor of 25 and 15. You can use prime factorization, or you can use your times tables. The greatest common factor of 25 and 15 happens to be 5. The next thing we want to take a look at are the variables. Are there any variables common between these two terms? If you look closely, you'll see that k is a variable that's within both these two terms. So let's make a note of that. Once you've done that, you want to look back at the exponents of these k's. You want to look for the lowest exponent. The lowest exponent here is 4. At this point, we want to factor out a 5 and k to the power of 4. So let's go ahead and do that. In brackets, I'm going to put 25k to the power of 6. And I'm also going to put 15k to the power of 4. I'm going to divide both these terms by 5k to the power of 4. Let's go ahead and simplify this expression. The 5k to the power of 4 remains the same. 25 divided by 5 is 5. K to the power of 6 divided by k to the power of 4 is k to the power of 2, because when you're dividing powers with the same base, you just subtract the exponents. 15 divided by 5 is 3, and k to the power of 4 divided by k to the power of 4, that just cancels out, so you do not need to write that in. However, if you wanted to apply one of the power rules, you can say k to the power of 4 divided by k to the power of 4 is equal to k to the power of 0. But anything to the power of 0 is 1, and that 1 just disappears anyways. So it's up to you if you really want to do that. Therefore, our expression of 25k to the power of 6 plus 15k to the power of 4, when factored, happens to be 5k to the power of 4 bracket 5k to the power of 2 plus 3 bracket. And like we did before, you can always check your work by using the distributive property. In our fourth example, we want to factor this expression fully. The first step is to rewrite the question. Once you do that, you want to take a close look at the numbers within these three terms. I have a coefficient of 21, a coefficient of 28, and a coefficient of 7. Let's find the greatest common factor of these three numbers. If you use prime factorization or your times tables, you'll determine the greatest common factor of 21, 28, and 7 to be 7. The next thing you want to do is look at the variables within these three terms and see if there's anything common. I have a c in each of these three terms, and I also have a d within each of these three terms. So let's make a note of that. Now I'm going to look at the exponents for these c's. I have a 4, a 2, and a 1. I'm going to use the lowest exponent of 1. I'm also going to look at the exponents of d, which happen to be 3, 5, and 3. The lowest exponent is 3. At this point, I'm going to factor out 7, c to the power of 1, and d to the power of 3. You'll notice that I'm not going to write in the exponent of 1 anymore, as it's considered redundant. I'm going to rewrite my expression. Now I'm going to divide each of these three terms by 7cd to the power of 3. At this point, you can go ahead and simplify this expression. 21 divided by 7 is 3. C to the power of 4 divided by c is c to the power of 3. D to the power of 3 divided by d to the power of 3 is 1. We don't write the 1 in. 28 divided by 7 is 4. C to the power of 2 divided by c is c to the power of 1. I'm not going to write that 1 in. D to the power of 5 divided by d to the power of 3 is d to the power of 2. Now, 7 divided by 7 is 1. We're not going to write that in. C divided by c is also 1. We're not going to write that in. D to the power of 3 divided by d to the power of 3 is also 1. However, this is basically 1 multiplied by 1 multiplied by 1. We're going to have to put a 1 here. If you look at the bigger picture, you have a term being divided by itself. And when you have something being divided by itself, it's always equal to 1. Therefore, we've just factored our expression fully, and if you wanted to check your work, you can go ahead and use the distributive property. In our last example, we want to factor this expression fully. The first step is to rewrite our question. So 5x to the power of 5, y to the power of 3, plus 7w to the power of 5, and z to the power of 2. The first thing you want to do is look at the numbers within these two terms. I have a coefficient of 5 and I have a coefficient of 7. We want to find the greatest common factor of 5 and 7. Since these are both prime numbers, the greatest common factor happens to be 1. The next thing you want to do is you want to look at any variables that are common between these two terms. I have an x, I have a y, I have a w, and I have a z. However, nothing is common between these two terms. So I'm going to make a little note of that. This means the only thing I can factor out of this expression is 1, and that doesn't change anything. Therefore, this expression cannot be factored. So I'm going to make a little note of this. Cannot be factored.